Hello, my name is Leah Brauker and I will be discussing the importance of forces in equestrian show jumping. Show jumping is a sport where a horse and rider must clear obstacles in a specific pattern in a allotted amount of time. There are different variations of show jumping competitions that vary either in speed through the course, the height of the obstacles, and judgment on form or technique. This subject is especially exciting for me because I competed in hunt seat competitions which judge you on technique while clearing short fences. To clear the obstacles successfully, the horse must apply enough force to the ground to get to the correct height, especially in high jump competitions. The horse must overcome all opposing forces of gravity and the rider and tack in order to get off the ground. The mass of the rider and tack, the height of the obstacle, and the velocity of the horse at takeoff are variables that changes how much force the horse must apply to the ground. A system schema of horse jumping shows that the horse has direct contact with the ground the instant of takeoff, and the rider and tack feel force of gravity from the ground. The rider, horse, and tack are all in contact with one another. The horse feels a normal force upward from the ground at takeoff, while there's an opposing force downward by gravity and the contact force of the rider and tack. The ground had the force of contact downward from the horse as it pushes off at takeoff. For this project, I will only be analyzing forces in the y direction. To analyze the force exerted during horse jumping, I want to use the current world record high jump by Captain Lara Kubel and his horse Huasu. The jump was 2.47 meters high and the record still stands today. Huasu was about 500 kilograms and Lara Kubel's mass was about 70 kilograms. The saddle and bridle also contributed about 10 kilograms total. The impulse time for the hooves in contact with the ground at takeoff was estimated to be about 0.1 seconds. In order for Huasu to successfully clear the 2.47 meter jump, he would have had to get his center of mass to reach a vertical distance of 2.5 meters to account for his legs. Huasu needed to apply enough force to the ground to overcome gravity and the contact force from Lara Kubel. Using kinematics, we can estimate Huasu's vertical velocity to be about 7 meters per second, which we can use to find the force of Huasu onto the ground. If we use the force equals momentum over time equation, we can use his vertical velocity and the total mass of Huasu, Lara Kubel, and the tack divided by the impulse time to find that Huasu applied about 39,970 newtons to the ground to achieve the world record jump. To beat this record, a horse and rider would have to clear a 2.49 meter jump according to the Guinness World Records. Therefore, a horse would have to generate enough force to get its center of mass at a vertical distance about 2.52 meters. With a horse and rider similar in mass as Huasu and Lara Kubel, the horse's vertical velocity would have had to have been 7.028 meters per second with a force of 40,762 newtons to beat the record. This is about 792 newtons more than what Huasu applied. However, there are other variables we can manipulate to help beat the record with less force needed. To decrease the amount of force and make it easier for a horse to clear an obstacle, there are many variables we can manipulate to be more competitive. Using lighter tack or choosing a smaller rider will lessen the amount of force opposing the horse's vertical movement, therefore allowing the horse to exert less force and become less exhausted. This is true since force is calculated using acceleration and mass, where mass and force are directly proportional. There are also specific exercises that trainers use to strengthen a horse's hindquarters. This maximizes the force the horse can exert. The rider's position and technique is also important. Rising out of the saddle during takeoff and leaning forward keeps the rider centered over the horse's center of mass. This keeps the horse balanced and has less impact force down on the horse during the upward motion. Here is a video of me and my horse Lass in a hunt seat competition. Note that I lean forward and rise a little on my saddle during the jump. The forces in landing are also very important to consider to prevent injury or lameness in your horse's legs. Sand is an ideal surface because it increases the time to stop the downward motion of the horse and therefore decreases the impact forces exerted back on the horse's legs. Using Huasu's record jump as an example, we are going to estimate that the sand allowed a 0.2 meter displacement when the horse lands. After calculating acceleration upwards from the ground, we see that force of the ground back on the horse would be about 71,050 newtons. This still seems like a lot, but if it were asphalt, there could be an upwards of 71,050,000 newtons on the legs. In conclusion, forces are important in the sport of show jumping, and horses must exert a great deal of force to clear these impressive heights. The forces in horse jumping can be analyzed and manipulated to gain competitive advantage and to help minimize potential injury to your horse.